What's happening, dogs? Mr. Allen here with a little application of sequences problem here. We got Dr. Dre in the house, right? Celebrity appearance. He purchased a tree for his yard, and he was told every year that it would double in height. Forever? That seems weird. If it was 5 feet tall when he bought it, how tall will it be in 6 years and in 12 years? All right. So sometimes with these application problems, we'll even follow up and say, does this make sense? Can we really have this model hold true this whole time? So we'll address all those things. And I'm going to show you guys a couple different ways of going through this. First thing, I want to list out these first few years. So year 1, 2, let's say this, 1, 2, 3, 4, 5, 6. So years, okay? And then let's see here, height. So my height in the first year is 5. Height in the second year, it doubles, right? So times 2, that gives me 10. And then it doubles again. Times 2, that gives me 20 feet tall. Seems reasonable, right? Times 2 again, 40 feet. We're getting pretty tall here, man. Times 2 again, we got 80. And then we got 160 feet tall. That's a freakishly tall tree, I'll tell you what. So already by year 6, I'm starting to think, hey, man, maybe this model ain't quite right. But let's roll with it, okay? Let's roll with it for mathematical purposes, okay? All right, so I already know by year 6, it would be 160 feet tall, right? So that's my answer there. Let's write an explicit formula for this one here, and then let's figure out the 12 years so we don't have to keep on writing. So explicit, that's a weird E. And this is a geometric sequence, isn't it? Because it's doubling, it's multiplying. It's not a common difference or we're going up by the same amount. We're doubling each amount. So I'm going to have A sub n is equal to my initial height of 5 feet, and then I'm doubling it, so times 2 to the n minus 1. So really, I'm going to be doing 5 times 2 to the, we'll do the 12th year, so 12 minus 1. So it's 5 times 2 to the 11th power. Okay, I'm gonna bust out the TI for this one. All right, so 5 times 2 caret, which is right above the division sign, 11. And I go, oh my God. Let's see here. This is outlandish, children, but it is a number that is correct from the calculations here. We have 10,240 feet for this tree. All right. By the way, one tick mark like that means feet. Okay. Same as like FT. So that's just, there's different notations there as well. Just in case you didn't know my fancy notations. Okay. So that is definitely not going to be the case for a tree, right? But if we're saying that something is doubling and it starts out at 5, let's just say $5 is doubling every year, in 12 years, you're going to have that many dollars then rather than feet on a tree. Okay, so some models make a little more sense than others, but that's how we would work it out mathematically, just the application here. It does not make sense. Follow-up question, does this model make sense for a tree? No! Ridiculous. Maybe it'll double in height for like the first couple years in that like growth spurt, but then it will like probably like level out, right? Okay, cool. That's enough of this. Okay, have a great day.